Welcome back. Today again we are with a junior penetration tester pathway. Now in this video we will go over SSRF or server-side request forgery room. Now for your information, in the website there is another room that bears the same name. As you can see here, we have another room called SSRF that explains server-side request forgery. And honestly, this room is a bit more extensive in the way the information is laid out, and it is more, um, you know, detailed. You can attempt this room before. If you want to do the room connected to the junior pathway, I recommend first do the one that is not part of the pathway. Then you can attempt the one which we will do in this video. You can also find the walkthrough for this room in my channel under this video, Understanding SSRF, Server-Side Request Forgery, TryHackMe. Now in today's video, we will go over the room of SSRF that is part of the junior pentester pathway. So to start with, we have around 5 tasks, and the practical part is only in the last task, which is task 5. So over the 4 tasks here, or the first four tasks, you will have only explanations of the vulnerability. So basically, let me go over the questions first. So here are the answers for the first 2 questions, very easy. Now let's go over the examples of the server-side request forgery. So you can click on the view site button to view the interactive guide. So in here, it's explaining the various types of or various ways of exploiting SSRF or uncovering SSRF. As you can see, this is the URL that is expected by the web server to be sent from the client. So basically in SSRF, you will be manipulating URL parameters, much like you do when you exploit directory traversal or the IDOR vulnerability. So in here, the official or the expected URL start with API website thm/API/stock item, and the parameter here is ID equal 123. Instead, what will the attacker do here? They will just remove the stock, remove this part of the URL starting from stock, and replace it with user based on their enumeration of the site. So when they access or when they request the /API/user, the server will return the user information because there is no authentication controls. That's one type of SSRF. The next type is you also have directory/stock, and you have a parameter called URL. And the parameter actually, as you can see, the URL parameter equals to /item. It doesn't equal to an integer, right? And then you have another parameter called ID, which equal 123. So one type of SSRF is that you remove the value of the parameter, which is URL, and replace it with your own. In this case, the attacker just replaced the value of the expected parameter URL, the expected value of the URL parameter with this value. Basically, they do here kind of directory traversal to reveal the information under the user directory. So also you can use directory traversal to uncover SSRF. The last one is a bit tricky here. So we also have stock, and then we have a parameter called server equal API, and another one ID equal 3. If you went back to the last one, see the difference between them. Here we also have 2 parameters, right? URL and ID. And here you have 2, server and ID. But the difference is here we have question mark, and here we have and, which means here is conditional, but here it is not conditional. Okay. So even if the URL doesn't equal to /item, right, the server will still look for any stock whose ID equals to 123. But here the stock parameters are kind of conditional. The server must be equal to API and the ID must be equal to 123. So what does this have to do with SSRF? So basically, what would attacker do here? They would manipulate only one parameter. Okay, much like we did here. So here we did not change on the ID, we only changed the value of the URL. The URL equal to or equals in the attacker's URL to a directory traversal to the user directory. But in here, we manipulate, for example, the server parameter, we replace it with a value of our own. In the example here, the value is the attacker's website, API website.thm/API/user, right? And then the attacker has added another parameter called x and x equal, and then continued with ID equal 3. Now, what's the point of x? So the point of x is to ignore the rest of the statement. So let me tell you why x has been added. If you go back, so here the attacker has just manipulated or changed the value of the parameter URL, and now it is equal to slash user, right? But as you can see, they didn't touch the ID equal to 3. They just removed it. Why? You remove the ID equal 1 to 3 without any error from the server side, since there is no conditions here. It's not conditional. But here there are conditions. The server must equal to API and ID must be equal to 1 to 3. So how to get rid of this ID? What we will do here, the attacker had just added another parameter in the middle and x equal. So when you add this in the middle, the server will ignore the rest of the URL, which means the URL will become http website dhm stock server equal API website.thm/API/user, and that's it. So we want to get rid of the condition that ID equal to 1 to 3, and we want to display the user information. So you see, it's all about manipulating the URL parameters. You look at understand the current URL parameters. Is it conditional, whether it is conditional or not conditional, and you craft your own payload based on that. Basically, you will be changing the URL parameter to either equal a URL of your own choosing or a directory in the target server where you want to reveal it using directory traversal. Next, see this one. So here we have another one. You see, this is the expected URL. Stock question mark URL equal http API/stock/item and ID or question mark ID equal to 1 to 3. So as you can see, we have only one parameter, right? One parameter, URL, and the value is this one. Don't confuse the parameter URL with the parameter ID. The main parameter is URL, but the parameter ID is part of the URL that you have just inserted here. So you don't need to bother with this one. So one way to implement SSRF is to change this URL to a URL of your own choosing, as you can see in the hacker request here. The hacker has replaced the site here, or the parameter URL value, into completely different URL. And now the server will return or will send a request to the URL of the attacker's choosing, hence sending headers and revealing API information or API keys, as explained here. So here's an example. So we have, as you can see, using what you have learned, this is an example to reveal the flag. Using what you have learned, try changing the address in the browser below to force the web server to return data from https server.website flag question mark ID equal 9. To make things easier, the server requesting bar here at the bottom of the mock browser will show the URL that the website.thm is requesting. So we want, as you can see, this is the original URL, website.thm/item/2 question mark server equal API. But the web server now, as you can see down here, it is loading items in the stock. So basically, the parameter here is server equal API. And when we put server equal API, it will request the item from the API.website.thm, where the item ID equal 2. So now we know what is the parameter we will manipulate. Now we want the server to instead of loading items, we wanted to load this URL. Okay, so one easy way or one quick way to do that incorrectly of course, is to say that, yeah, I'm gonna just take the URL and take that and replace it instead of API and it will work. Nope, it's not gonna work. Since there is the server doesn't know the HTTPS here. At the same time, uh, as you can see, nothing changed in the request parameter or the request URL. So in order to do that, we have to do some trial and error. For example, if we type API here, you see we have two items because we are loading the items from the API website. Now, instead of loading the API website, we will load this site. But how to do that? As you can see, basically here, whatever you put here in as a value for the server parameter, for example, type hi. As you can see, what changed in the request URL is the hi. Now the server is asking hi.website.thm for the item whose ID equal to 2. Which means if we want to change on that URL and make the server load this URL, we will have to omit this part and take this part. Okay, enter. Now still not working. Why? Let's look at the URL, request URL. So indeed, now the server is requesting or is redirecting to our server to load the flag. But then we have another thing, as you can see. So we have this, but .website.thm, which is the rest of the original URL is stopping us from loading the original or the URL of our choosing. So what to do? What we can do to ignore this part? We can use the and x payload. So if we add and x here, it will ignore everything after 9. Everything after 9 is starts from the dot and ends with the 2. If you enter now, as you can see, you have loaded the flag. So that is one good example about SSRF. So as you can see, one key method of achieving successful SSRF attack is to monitor the request URLs. So you just enter here your payload and you use curl or perp suite to see the request headers. What is the website requesting? What are the URLs? What is the change in the parameters? All of these are key methods in achieving successful SSRF attack. Now, finding an SSRF, see if there are any questions to be answered. No, yeah. So this is a site called requestbin.com where you, if you want to monitor your HTTP request to web server, you just create one and do the work. Anyway, defeating. So here are some answers for this task. You can find the answers in the reading. Now let's do the machine. So we start the machine. So in this machine, we require to reveal the flag. We will be exploiting an SSRF vulnerability. But the way we will exploit this vulnerability in this example is kinda different than the previous methods. We will rely on the directory traversal to reveal a directory called private. So if you read introduction, we have two directories, /private and /customers new account page. When you create a new account, you will be able to see your account page. But if you want to access the /private, you will not be able. So basically, one could think that there are some permissions preventing the regular user from viewing the /private, but actually you can still manipulate, look at the URLs, look at the parameters, and see if you can conduct an SSRF attack. Now let's wait for the IP to show and we will start. Okay. Let's close these. Well, honestly, let me close the browser and open it again. Okay. So first we head to customers and we create an account. You can choose any email address. There will not be any confirmation email sent to your email, so basically just any email would work. So now we have created our account. Now if you go to your account, click on update user, click on support tickets, I guess. Let me check what is the URL. So let's go to that URL. So in this URL we have avatars, and we can update our account with the desired avatar. So if you choose one, for example, update avatar, you see avatar updated. If you choose anyone like that, you see your avatar has changed. Now, if we choose this one, for example, as you can see, we are able to change the avatar. Now, the vulnerability in this side lies in the avatars. So if you click on that avatar again and right click on inspect element, click on inspect element. So see, this is the element of the avatar, right? Now there is the URL of the image. So this image has this URL as a value, /assets/avatar /6.png. Now basically, a primitive thinking about SSRF would say that, yeah, I'm gonna replace the URL here with my own URL or with /private. If you try to do that, you can try that, of course. Let's try this. If we try now to replace this with /private and click on update avatar, you see nothing revealed, right? If you check back on this one, you see the URL stayed the same. Even we have changed the URL, but there are some authentication and verification methods on the server side that makes sure the supplemented URL here is actually the image URL. So let's take a look at the second one. So we have type, radio, name equal avatar, and value equal assets/avatar /6.png. So we can also play on this one. What we can do here, we can follow the formula here. So assets, we need to change that. Let's leave it to A. Okay, and then in order to access the private here, what we have to do here, we have to do some sort of directory traversal. So point, and then we type private. Hit enter. Update. You see avatar updated. So if we take a look now, after updating the avatar, you see the value returned back to its original value, or the value here. It's assets/avatar /6.png. But if we go up and take a look, if you want to make sure that whether the /private content has been loaded right here or not, we want to make sure you want to look not here, but we want to look at the original form. So these are the avatars elements. Now if we expand this, you see the current avatar here looks empty, right? Our current avatar that we have updated, because as you can see, the URL points to a base64 value. If you take the base64 value and decode the value in Linux or in, Linux would work. So echo you see this is the flag. So basically, when we changed on the value of the avatar with a directory traversal to the private directory, as you can see, we have updated the avatar, but something looked off here. The avatar looked empty. That's why we inspected the source code of the form, and we saw a base 64 value in the image URL. So that was for the, or that's the end of the SSRF room. I hope you enjoyed the room. If you found some ambiguity in the room, I advise you to get back to or do the room that is not part of the pathway. It contains more explanations, and you will end up having or being more familiar with the vulnerability, and then we'll be able to attempt this one. So that's it for today. See you in the next video.